I think it's time. Let's kick it off. I know everyone's probably a little tired. It's post-lunch. We're blowing through nap time right now. I get it. So I'll try to keep this energy up and have a little fun with you guys today. My name is Burton Smith. I'm really passionate about web development, particularly web components. Obviously, I got my own nerdy apparel and everything for it. Yes, I made this myself. This isn't something you can buy anywhere. It's custom. But I work for a nice little startup called Microsoft. Most people have never heard of it, but we're growing. We're getting there. I've been with them for about 3.5 years. And today, actually, I'm going to talk about the story of Microsoft and working with web components at Microsoft and how, at least in our little area that we're in, why we're using web components and how they've benefited our ecosystem and hopefully help translate that into how they could benefit you in what you're doing today. So I work on a little area called Partner Center. That's where people go and manage apps in the App Store, where they can go in and manage their Office 365 licenses, their Xbox licenses, all those things that they buy in bulk and resell or whatever it may be. So the Partner Center portal is kind of where a lot of our components are used today. Now, the interesting thing about Partner Center is it has this really fun architecture. I don't know if you guys have heard of it. It's called a micro front-end architecture, right? And I use fun very loosely, where basically they said, okay, team, you guys, everyone's got their own little piece of Partner Center that you're working on. Just choose your own adventure, right? Just choose your own technology that you want to use, and hopefully it works out in the end of the day, right? That's a very optimistic point of view. But they quickly saw that there were issues. We had, our .NET team was using like jQuery instances. We had our React team using a different kind of components. We had our Vue team making up their own. It just became very disjointed. So as a user went from the start of their experience in the Partner Center portal, they started in one experience, and it just kind of went through this roller coaster of an experience all the way through the end. Dialogues wouldn't behave the same. Buttons were different shaped and different colored sometimes. They would perform different actions when you clicked on them. It was just kind of a Wild West out there, right? It got very weird for the user as they started using the Partner Center portal. And so they said, you know what we need is this thing called a design system. How many of you have heard of a design system before? Yeah, design system is a really awesome idea. It's just basically the idea of, hey, this is how we build applications, right? This is a consistent way of how we build and style our user interfaces to drive consistency. Well, Microsoft has a design system. It's called the Fluent Design System. It used to be called Fabric. Now it's Fluent. And it has a really good component library. The only problem is that it's only written in React. So the management team all got together and they said, okay, that's all right. We will just make everyone rewrite their code in React. And as you can imagine, it wasn't super well received by a lot of these teams. They weren't super jazzed about, one, having to rewrite all of their code all over again, but also being strong-armed into a specific development environment. They had chosen their technology for a very specific reason. That's what they knew well. That's where they were most productive with. So now we needed to find a different solution. Was there another way besides trying to force everyone to now use one single framework and one single component library to trying to find a way to continue to get the benefits of a design system without having to make that big, huge switch for everyone? So that's where this idea of web components came in. Now, web components, for those who don't know, they are the browser's way, an HTML standard way of encapsulating markup and style and behavior into a single component. So most of us are familiar with React or Vue or Angular or a lot of these other JavaScript frameworks, and they all have a component model, right? They all have a way of encapsulating markup, style, and behavior into a single reusable piece of code that can be, applied in different places throughout your application. Well, believe it or not, the browser has had this for quite some time. Web components rolled out about when HTML5 rolled out, right? That's when this whole idea came about. The only problem is that there wasn't a lot of great support for it. Namely, Internet Explorer, right? Internet Explorer didn't have very good support for it. There were all kinds of cool polyfills and shims and things to make it work, but it just took a little while to take off. Well, the good news is, so there's this cool site, I don't know if you guys have ever heard it before, arewebcomponentsathing.com. I'll save you a click real quick since there's no Wi-Fi. I went in and preloaded it. There you go. Hold on, wait. Oh, I got to get it. Right there, see? Yes. All right. So if you scroll down on this page, it's going to go through and show you a lot of different companies that are using web components. Now, web components are incredibly good for a lot of reasons, but we're really starting to see them pop up a lot in enterprise environments where they have huge ecosystems with a huge diversity of technologies that are being used. They need the ability to reuse code across all of those platforms if they can. So this idea of web components, a standards-based way of encapsulating our HTML, CSS, and JavaScript, that's kind of enticing, right? So the idea is that, if we write it in the standards-based way, we get this cross-functional, reusable set of components that we can now plug and play in a framework-agnostic way. They should play nice in Angular, React, Vue. We'll talk more about that in a second, but that's the promise of web components, right? So let's come back in here. Oops, that's not what I wanted. There we go, that's what I wanted. So what are web components really? Because you hear that word a lot. The tricky thing is that web components really isn't a thing. It's really kind of a combination of things. There's three technologies that typically comprise web components. There's custom elements, where it's literally writing your own HTML elements. There's shadow DOM. This is one where most people are kind of like, I don't really like web components because of shadow DOM. And that's where a lot of the learning curve comes from. But shadow DOM, we'll talk more about in a second, is this nice way of encapsulating and protecting our components from being manipulated from external sources. And then HTML templates. And HTML templates for a long time haven't gotten a lot of love, but they're really starting to have a resurgence. And we'll talk about each piece of these here in a second. So custom elements. Really, I'll read this so that if anyone can't see it. The ability to create custom elements that encapsulate your functionality in an HTML page rather than having to make do with a long nested batch of elements that together provide a custom page feature. So really, it's literally teaching teaching the browser about your component so that it can be its own custom HTML tag. Kind of awesome, right? So when you look and you inspect the page view, if you do that with React, Angular, or Vue, all you see is just markup, right? You just see whatever that JavaScript engine translated your components into and gave the final output. Not with web components, or at least not with custom elements. Custom elements will actually have its own tag. So you can see in the DOM as you view source, oh, there's my input, and there's my button, and there's my, whatever it may be. So it's kind of cool to be able to see that encapsulation there in the browser, and it makes it a lot easier to be able to track your code in the source. All right, the shadow DOM. Like I said, this one is where a lot of people get a little weird about web components. All right, the shadow DOM API is a key part of this, providing a way to attach hidden, separated DOM to an element. This provides the ability to keep the markup structure, style, and behavior hidden and separate from other code on the page so that different parts do not clash and the code can be kept nice and clean. So literally what happens is the shadow DOM creates this thing called a DOM fragment, and it exists outside of the flow of the rest of the code. So whatever's happening inside of the shadow DOM isn't manipulated by what's happening outside of it. So if I say all of my buttons need to be bright pink, all the buttons on the page will turn bright pink except for everything that I've put inside of my shadow DOM. That'll be protected by the shadow DOM. That'll maintain the styles that I applied inside of the shadow DOM only. Likewise, any of the styles that I put inside of the shadow DOM, if I said, okay, now all the buttons need to be blue inside of my shadow DOM, won't leak out of my components and affect the components outside of the page. Now, this is really handy, especially if you're trying to maintain a certain level of integrity with your components, right? We had a situation a couple years ago on one of, this wasn't at Microsoft, this is pre-Microsoft. So we're on a very large e-commerce platform. And one of the challenges that we had is that we had a consulting team come in and work on a piece of our project. This was a very old project. It used jQuery and Angular 1.3. All right, it's pretty old, but this was only a few years ago. So they installed a jQuery plugin that would style all of our select components, at least for what they were doing on the page. So they installed this jQuery plugin. They wanted some specific functionality, some specific styling. The problem is that when they did that, they used a selector that just used select, right? They selected anything that was using the select tag. There was no specific IDs or classes that they applied that selector to. So it said, okay, all of the selects on the page now need to apply this new styling and behavior for this plugin. Well, it worked really well for the change that they made, right? For the piece of code that they were working on, it worked great, except for it broke all of the other selects on the page because it now was trying to apply a different set of logic. Having this kind of content inside of a shadow root would have protected that situation from happening, right? It keeps it isolated, keeps it consistent. So it's very, very powerful and very helpful. Now, with that being said, it also creates a learning curve. You now need to say, okay, I can't have a global style sheet that styles all of my components on the page. I now need to take into account, how do I style my shadow root content? Good news is there's lots of great APIs out there that allow you to do that and pass styles into your shadow root if you want, right? You opt into it. It's your choice. So a little idea of just kind of how this is architected. So we have, oh, here we go. Hold on one sec. Come on. Uh-oh. I broke my pointer. Oh, it's on the page, though. You guys can see it. Yeah. So up there, we have our custom element, right? Right there at the top. And then we have inside of there, we have this little, it looks like an element almost, right? It's called the shadow root. And it kind of behaves like an element. That's where our DOM fragment starts. All right, and then inside of that DOM fragment is all of our content within here. And then we have this stuff that's in what we call the light DOM. All right, we have the shadow DOM and we have the light DOM. Light DOM is really just the regular DOM, but we like to differentiate it because we like to be weird. So we have the shadow DOM content and then we have the light DOM content. Shadow DOM content is styled within the shadow root. Light DOM content can be styled from anywhere. So these little checkbox items can inherit styles from the rest of the page if we want to. It depends on how we have that set up. But the idea there is that we have a separate DOM fragment by using a shadow root. Okay, HTML templates, like I said, these didn't get a lot of love originally, but they're really starting to pick momentum. The template HTML element is a mechanism for holding HTML that is not to be rendered immediately when the page is loaded, but may be instantiated subsequently during runtime using JavaScript. So really, all it is here, actually, oh yes, I got one. Okay, it's a template tag. Anyone use Vue or, let's see, Svelte? They all have this notion of a template tag. It's not too dissimilar from that. A template tag is a way of encapsulating DOM that you can then copy and stamp out wherever you want to. Now, the cool thing about a template tag is that when it renders on a page, it's totally inert. It doesn't do anything. So even though I have this script alert inside of there, it will never do anything until I actually take that template, clone it, and apply it to the DOM. Then it will fire that JavaScript in there. So it's kind of cool that you could do that, right? But most people are like, oh, that means I have to like side load these templates onto the page, and then my web components have to go and like grab these templates and use an ID and try to stamp them out for my component instances. It's a little awkward, right? So that's why they haven't really gotten a lot of love. Most people are just like, well, I'll just use JavaScript to apply the internals of that component for me. I don't really want to stamp out this template, but this is where things are starting to get cool. We now have this thing called declarative shadow DOM. And it's this idea that now we can apply a shadow root declaratively to any element that we want to. So I'm using this on a div, right? I can say, okay, all the contents of this div, put it in a shadow root, protect it, put it in its own little DOM fragment so it doesn't get, it's outside of the flow of the rest of the document. Now, we can do this with also our custom elements. We can add that as a shadow root. And then if we want, we can use JavaScript to upgrade it if we want to have a full-blown JavaScript features. So this is starting to become more popular as we look at how do we server-side render our web components? How do we make our web components run fast before JavaScript loads and things like that? So this idea of declarative shadow DOM has taken on a new feature. Now there's another facet coming hopefully soonish. It's the idea of declarative custom elements, where we can actually define custom elements using using HTML instead of JavaScript. So I can literally say, define my element, have a shadow root internal in there and all of my styles and everything, and have a component, a web component, completely JavaScript free that I can run using HTML. Kind of a cool idea. Now, with that being said, the promise again is that, hey, we can use these wherever we want to now, right? These are just DOM primitives. I can use them like HTML. I can use, HTML works everywhere. It works in Vue, Angular, React, .NET, PHP, whatever. I should be able to plug and play those wherever I want to now. Well, it doesn't always work that way 100% of the time. There's this really cool website where there's a team of devs that have put together a number of tests to make sure that they play well with web components, to say, okay, well, how does Angular actually do when incorporating web components? How well does React do? How well does Vue do? Blah, 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 right? Now, the cool thing is that for the longest time, most frameworks played incredibly well with web components. They built, they've integrated very nicely with them, except for one. Do you guys know which one that is? React. Yeah, that was kind of our problem child for a long time. Good news is, as of React 19, there is now web component support. They now built that in natively. Before, it's okay. We still could use our web components in React. We just had to provide a wrapper, so it would provide an integration piece between our web components and the React layer. Now, not so much anymore. React 19 has built that in, and now we can start taking advantage of that. How many of you are on React 16? A lot of our team at work is. How many of you are on React 18? Oh, not bad. React 19? Oh, we got one person hanging out in the front. All right. So obviously, it's going to take some time before teams are able to get to that point, which is great because we've been working with React for a long time. There's still a lot of great options for working with web components in React until we're able to switch to 19. So that's really great. So custom elements everywhere. That's a great tool for developers who are building web components to be able to say, hey, what special considerations do I have to make knowing that my devs are going to be using X framework, right? I need to know that so that I can make sure that I am either providing them the tools to work with it, or that I'm building my components in a specific way that they can consume those in a user-friendly way. Okay, so why not web components? All right, this is great, right? The idea of web components, that I can plug and play these wherever I want to. I can write my design systems and my component libraries in web components and use them everywhere. That just seems like they should take off and be super easy. It's a no-brainer, right? Everyone should just do it. Except it's not always rainbows and butterflies, all right? So server-side rendering. In order to create a web component, you have to be able to define them on the window object. It's window.customelements.define your object. Well, when you're server-side rendering a component, guess what's not there? A window. The window's not there, right? It's in a headless state, usually pre-rendered by JavaScript. There's no browser usually even there to be able to execute it. So the server-side rendering story of web components has not always been great because you can't really server-side render them. Now, there have been attempts to do this where they use declarative shadow DOM, like I had showed you before, where they, kind of pre-generate that initial load of those components inside of each element. The only downside to that is that in order to do that, one, you have to tap into that ecosystem's server-side build environment. So you have to do it for Next, you have to do it for Nuxt, you have to do it for Astro, you have to do it for whatever it is you're using, VitePress or whatever, right? So you have to do it for each one of those, and then it stamps it out for each component use. So if I have 30 buttons on the page, that means I had to stamp it out for 30 instances of that button, which means it makes your DOM size just blow up, right? It's huge now. You have a ton of content that you're passing across the wire now to be able to try to alleviate some of that server-side rendering. So there's options out there. So my rating scale here, in case you didn't know, it's either smiley, slanty smile, or sad. Smiley means it's great, we're good, you can do it. Slanty means it's getting better or it could be better. And sad face is it's not good at all. So I have a slanty on there because I think we have a partial solution for that, but I don't think it's a great one. I think hopefully there's better solutions coming down the pike. Now, I will say, I mentioned before, declarative custom elements. I think there's an opportunity there to really help us resolve this problem in a really clean way for developers. So I'm hoping that that will come soon. Search engine optimization. Anyone working with search engine optimization, marketing teams, making sure that your site can be found by the outside world? Yeah. So there was a lot of concern for a long time that web components aren't SEO friendly. So I took it upon myself to find out if that were true. And I went in and found whether or not the search engines play well. I wrote an article on it. Turns out they actually work really well with search engine optimization, and the browsers wait and load web components so that the contents can be discovered by indexers. So that's a win. Requires JavaScript. This is true. You can use declarative shadow DOM to kind of work around that a little bit, but it's, again, not a great solution. But yeah, you have to use JavaScript to define your custom elements. Hopefully declarative custom elements will help resolve that for those teams that either have JavaScript fail, that for some reason have JavaScript blocked. Does anyone work in an environment where you're not allowed to use JavaScript, first of all? Okay. I've heard people like, oh yeah, there might be some companies that turn off JavaScript. I'm like, what are they doing? Like, how are they functioning on the web? But there are instances where JavaScript fails, right? Or there are instances where something doesn't load right. And then there are some components that actually don't need JavaScript whatsoever, right? Why should my badge component that has zero interactivity of any kind, it just displays content, I don't need JavaScript for that. It's just HTML and CSS at that point. So there are instances where we probably don't need it. Browser spec adoption. Now this is always kind of going to be a slanty thing. The web works at a very slow pace, right? Because we're working with the actual DOM primitives, it takes a little while for these to be adopted and implemented by the browsers. A lot of times we have pretty good shims and polyfills for it, but you're working at the speed of the browsers, so it sometimes can be a little bit slow for some of this stuff. Form integration. Remember how I said you can, with the shadow DOM, you could isolate DOM fragments and put it in its own kind of DOM isolation? Well, for a long time, that means that I have an element that needs to be able to talk to a form element, right? I have an input element inside the shadow DOM that needs to be able to communicate to a form element what the values of that are. So when we submit it to the server, we submit the right information. For a while, that didn't work super great. Good news is that has been fixed, and that is works really well in current implementations. Legacy browsers, good news is, if you're on an evergreen browser, you're in good shape, right? These evergreen, especially Chromium-based, Firefox, Safari, all have pretty great support for web components. Anyone still rocking IE out there? IE 11? No? Anyone? Oh my goodness! I think this is the first time I've had no hands come up. Good job, team. Good job. I'm proud of you. I'm proud of you. All right. So yeah, legacy browsers. IE was really the big holdout. As soon as IE 11 died, that's when everyone was like, oh, okay, we can start using web components now, right? Learning curve. Web components and custom elements themselves are a different paradigm, all right? It takes a different kind of mindset when you work with web components. The shadow DOM, again, different kind of mindset. If you're used to working with JavaScript frameworks and components in those kind of environments, it's a different mindset. You need to take into account, strict style encapsulation and slots and how those interact with internal elements and things like that. How the custom element life cycle works, right? It has its own life cycle hooks and everything. So there's a little bit of a learning curve as you start to learn how to use these custom elements, especially if you're transitioning from a JavaScript framework. It's so funny because you can tell when we get new people onboarded, they're always like, well, why can't it do this? And why can't it do that? I'm like, oh, you were on React. Oh, you were on Vue. Oh, you were on this. You clearly can tell. They're like, oh, I understand where you're coming from. I had those same questions when I came on. It just works a little bit differently, right? It has a different paradigm to it. Component registries. Now, this was a sad face for a long time. Now, anyone working in a micro front-end environment? Were you? Okay, cool. So micro front-end, again, it's kind of a choose-your-own adventure where, you know, they might have multiple multiple pieces of an application that are loaded by a different team, right? So my header might be built by one team, my sidebar by another, the main content by a third team even. So here's the tricky part. Web components can only be registered one time, right? You can only have my element or my button or my input registered one time for the entire browser session. So what happens when the header decides to load version 1 of our component library, the sidebar decides to load version 2, and the main body's loading version 3? Which one does the browser decide to use? Whichever one loads first, right? Whichever one loads first, that's what we're going to get. Well, guess what? Let's say version 1 loaded first. 2 and 3 are going to have a way different experience with their components than they originally thought they were going to have, right? Because now they're working with version 1, and they thought they were getting 2 or 3. Well, there's now this new feature being set. I think Safari just recently implemented it, and I think they were the last one, or they're working on it. It's very close. I know it's very close. But it's the idea that you could scope a registry to a shadow root or a defined part of the DOM. So you could say, okay, my button, only scope those to the header portion. So our team has the header portion, scope all my buttons to the header portion, make sure that they don't affect anyone else's button on the rest of the page. Sidebar, okay, we're going to isolate our component registration to only the sidebar so that it doesn't affect anything else on the rest of the page. So now we have these scoped component registries which allow us to have multiple versions of our components on the same page at the same time, which is pretty awesome. So it's slanty because I think we're almost there. We're almost ready for everyone to be able to take advantage of that. And once we do, we can start seeing teams safely and comfortably start using web components in a more diverse way. Okay, so now that we talked about, okay, why not web components? Let's talk about how have I seen teams taking advantage of web components and how have they benefited from it? So I recently talked to a team, well, I guess recently, it was maybe 2 years ago, that they're a Vue shop through and through. A long time I would say, for longest time, people would say, well, we're only an Angular team, we're only a React team, why would I ever use web components? And I used to be like, well, if that's your bread and butter, stick with it, like, because you'll never, you know, there's no reason to switch to it. Well, I ended up having to eat my words a little bit because I came across a team where they are a Vue shop. They have 3 applications. One is their core application. They have an internal application. That's their main application is written in Vue 1. Their internal application is written in Vue 2, and their new flagship application is written in Vue 3. And they have a design system that's also written in Vue 3. Well, guess what? If they want to reuse their design system, what do they have to do? Upgrade their other applications to Vue 3 to be able to take advantage of that, right? So I said, well, what if you wrote your design system in web components? Because that'll play nice across all 3 of those. Plus, that will significantly reduce the amount of work that you have to do as you upgrade your applications to the next version of Vue, because you can just reuse those same elements. You don't have to upgrade those elements too. And so the idea of being able to use web components to help progressively enhance your application suddenly became very appealing in those scenarios. Another one was with a company that I was talking to where they are a consulting agency. And they work with lots of different companies, and they often go in and build wholesale applications for different, hospitals, schools, whatever they may be. Wouldn't it be great if you had a white label component library that you didn't have to rebuild every time you went to a new customer? And you could just say, hey, we have this white label one. We can now brand it to whatever your brand is and save you a ton of time by using our web component library. And guess what? If you want us to write the application in Angular or Vue or React or whatever it may be, we can still do that. But we have this underlying component library that you could take advantage of right now that will save you a ton of time. Okay, so being able to have that in your tool belt is really powerful and a huge saver. Okay, now using web components. This is going to be kind of squinty. I apologize, but that's okay. I don't really intend for you to read it. So when you create an element, a web component, you have to extend it from an HTML element. It's a class-based system, so you say class, my component extends HTML element, right? It's a JavaScript class. Then you have a constructor that says, okay, we're going to go ahead and fire some code whenever this component gets used and instantiated, attached to shadow root. You can add, actually don't add child elements in here. That's not good code right there. But you can do all kinds of stuff in there. Then in connected callback, that's where you're going to want to add some logic, maybe add some content to your component inside the shadow root. Then in there, you're going to say, hey, wait, we have attributes. We want to be able to pass data in, right? Whether it's checked or required or value or whatever. We want to pass that data into our components. Well, we have this special lifecycle hook that listens for changes on that. Okay, well, we're going to tell them what attributes to look for so that we know that we need to fire an event anytime those change. Well, then we need to say, okay, what are our properties for our component? We're going to add class properties, getters and setters, all that jazz. Then we're going to say, okay, now anytime any of our attributes change on our component, we got to do something. So we're going to say, okay, if this attribute changes this way, we're going to add this value and set this property inside of there. If this attribute changes, we're going to add this value in that property, blah, 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 right? And then you're going to say, okay, now define my custom element, all right? Now, with that all being said, it can be kind of verbose, okay? But the good news is that most people don't actually write web components using raw JavaScript. Now, there are a couple psychopaths out there that do that. I won't lie. They're like, I love it. I'm like, okay, that's okay. But most people do not actually write vanilla web components on a regular basis. Most of the time, they have something that helps them. So there's some great libraries out there, Lit and Fast. These are very similar products. These sit on top of the existing component the existing spec, right? And they're basically great abstractions to help clean it up and simplify writing components. And they're very lightweight, very thin library that you load with your components that allow you to have a good developer experience and actually optimize a lot of the loading and the rendering of your components. Now there's also compilers where you write it in a specific language and then it will compile down into web components at the end of the day for you. So, Stencil, Svelte, those are all compiled solid. They'll compile it down into a raw web component form for the browser to consume. Very lightweight, very efficient. Downside to that is that you lose some functionality. Anytime you use a compiler, they're going to have a very opinionated way for you to write and author those components. So you're going to lose a little bit of value, a little bit of the raw functionality, but you may gain some value in other ways that you appreciate. Now there's also this really nice way of creating a framework wrapper, sort of say. I don't want to say wrapper because, yeah, I would say it's a way of way for the framework to take its authoring experience for components and kind of wrap it and output it into a web component that can be reused. So there's Angular elements, Preact, and Vue. They all have mechanisms for you to translate those framework components and output them into web components, which is pretty cool. The downside to these, though, is that you tend to get a little framework overhead with it. So your component can be a little bit bigger than you might have anticipated if you were using a vanilla web component, because you get a little bit of framework extra in there that helps with the binding and the syntax and everything that you originally wrote. With that being said, there are a lot of options. Webcomponents.dev is a great site. It's a playground where they have like 65 different ways to write a web component, something like that on there. And you can go in there and click on one, and they'll give you a little sandbox where you can play with it and be like, oh, let me get familiar with this syntax. I want to see what it's like to write a component in Vue or Svelte or whatever. And it'll give you a little sandbox for you to play with and try it out. It's really cool. So I highly recommend it. Check out webcomponents.dev and see what each of these frameworks offer and see if there's some that work with you. Now, with that being said, I will say, hands down, the hardest part about building with web components is learning everyone else's framework. Now, I'm not the biggest React.js fan. It's okay. I don't hate it, but that's not my go-to choice. And I was like, oh, you know what? I really like web components. This is great. I love web components. And I learned that, and I got involved in it. And now working on a team where we have lots of different kinds of developers, guess what I end up writing a lot of code in now? React, because I end up like showing React devs, oh, here's how you integrate with web components in React. So I spent a lot of time in React land when I thought I was actually running away from it by using web components, and it's not really the case. You spend a lot of time educating people on how to use your web components, and that usually entails you learning a little bit about each framework and understanding how those work. Now, integrations. The promise of web components is that these plug and play in each of these environments, and that you can use web components, you know, agnostically, right? You can just use them like HTML elements. But it's not as easy as it sounds, right? Right now, if I were to create a custom element and I were to go use it in a Vue application, yes, I could use that custom element in the Vue application, but guess what? I don't have autocomplete. I don't have syntax highlighting. I don't get validation for my APIs. I don't get all this other cool stuff that if I were writing a Vue component, I would get that stuff, right? But because I'm doing it in a way that Vue probably doesn't fully understand, I lose some of that goodness, right? Does everyone recognize all of the icons on there? Yeah, this one? Oh, no, that's not what I wanted. I'm sharing my secrets. This one? Stencil. Yeah? That's what you use? How about this guy right up there? Web components. All right. How about this one? Storybook. Who's using Storybook? Yeah, I've been working with the Storybook team on web components. I have a web components helper library, and I've been working with them to say, hey, how can we improve Storybook and web component integration and making that a great experience? And so there's some cool stuff coming in version 9, let me tell you. Hope you're ready for that. All right. Now, with that being said, there is a great tool out there called the Custom Elements Manifest. All right. This is a superpower for web component authors. And what it is it's a tool. There are tools out there to generate your custom elements manifest for your components. And what it does is it goes through your code and collects all of the metadata about your components. It'll grab all of the API information, all of the custom CSS properties, all of the slot information, all of the custom event information, all of your methods, your properties for your classes, all of that stuff, and put it into a giant JSON object. So now that you have all of this metadata about all of your components, you unlock a ton of capabilities, okay? And you get a lot of really cool toys, all right? So this is my site, WC Toolkit. I've been writing a lot of toys, I guess you could say, for a while now. And I've been trying to bring them under one umbrella. So the WC Toolkit is kind of a place where I'm starting to try to put those together in one place so that devs who are building with web components can have a place to go and say, hey, I'm integrating with Storybook. How do I do that with web components? Hey, I'm integrating with React. How do I do that? I'm integrating with Vue, JSX, whatever it may be. So the Web Components Toolkit ideally is something that you can take and just grab those packages that are documented in here and apply them to your project so that you have great integration with your components, right? We want to be able to have syntax highlighting and autocomplete and API validation and all of that stuff. So that's what the WC Toolkit is. And I keep adding to that on a regular basis, so just keep your eyes open. I post about them all the time too. So that's a fun playground for web component devs. API details. Who likes writing documentation? weirdos, what? Yes, oh, I love writing API docs. Actually, don't get me wrong, I actually really do. When I have well-crafted docs, I'm like, beautiful, right? It's so great. But ideally, we want to minimize the amount of code doc writing that we have to do on a regular basis. Well, since we have all of that API information documented and detailed in our custom elements manifest, well, why don't we just use that to document our components too? So we can pull all of that out. And so there's a tool that I created called the WC Docs that generates basically an output that you can put right in your documentation to document all of the APIs for your components for you. So it's a very handy tool. Same thing with being able to share code samples and interactive examples and demos. I created the code bubble, which allows you to create code snippets in there and open them up in Code Sandbox or in CodePen or StackBlitz or whatever you need to use. You can click that little sandbox and it'll open it up in there, and you can share them with people and document your components and make them easy to understand and reuse if you want. Okay, now this next piece. All right, so according to AI, that is what AI looks like, by the way. I asked AI to draw a picture of AI. So now that we have all of that information about our components in the API, we can start doing some very interesting things with AI, right? We can start creating tools to say, hey, I need to be able to generate a page with these kinds of features on it, and you need to be able to use this library. So now it can reach out to our library, grab the custom elements manifest, which has all of our APIs documented, and make sure that it's creating and using our components in an accurate fashion, right? And we can also say, hey, I'm upgrading from version 7 to version 8 of the component library. Hey, will you update my project for that? Just a little, add a little chat in there. Oh, I can analyze and see what the API differences are and make sure that they migrate successfully with those new things. Those are coming soon. They're not ready yet. I can't demo anything yet, but those are some things we're working on. Also, to say, hey, we have this Figma of a UI, and we need to be able to translate that into code using this component library. There's a team at Microsoft right now working on that to be able to translate Figmas directly into code output, which is pretty exciting. So being able to have this kind of granular knowledge about our components is very powerful. All right, so back to our story. Okay, so we're in this micro front-end environment, right? We have all these teams using different technologies. So now we need to be able to say, okay, how do we make that consistent? And that's where we came in with the Harmony component library. We created a design system built on web components that can now span each of these environments. And now we need to be able to create integrations for each of those and provide tooling for them and documentation and all of that stuff. So that's where a lot of this tooling came from, is really being able to communicate and work with these teams about it. Now, an interesting thing grew from that is we have Partner Center, and all of a sudden we now have all of these other platforms that are like, hey, we want what you have. That's pretty cool. And they started using it across the other platforms. Well, then this other thing happened where these teams started talking about, hey, we like Harmony. This is great. We want it too. But we don't really want Harmony. We want kind of our own thing, right? We want to be able to create our own component library. Now, I want to call out that I am totally aware that this is a freaky image. There's a lot of weird stuff going on, and these faces are really weird. Yeah, I did that on purpose. I like looking for the weirdest pictures that AI can generate for me. So you got a lot of extra arms. I don't know what's going on with this company, but there's a lot. Don't drink the water at that company, whatever's happening. So with that being said, we were trying to find a way to create an environment agnostic way for teams to create their own design systems built on web components. And so that's where this idea of Project Charm UX came from. I gave this same talk last year, and I talked about this last year, and I'm like, it's almost out. And guess what? It's almost out, all right? Here's what's happening. So I don't know if you guys have ever seen your company where, they like to grab the ant farm once in a while and shake it up real fun and try to, rework things. Well, yeah, Microsoft likes to do that a lot too. And so they've done that a couple of times. So it's kind of slowed this down a little bit. It's not done. It's not dead, but it slowed us down. And so, but we're still pushing to get this out and make it an open source project. So that if you're thinking about creating a web component library, you can leverage Charm to be able to start not from 0, but start from 1 and create your own design system. We're already using it for 2 component libraries internally at Microsoft right now, and we're just actually working on the details of getting it to be an open source project as well. So all of you can take advantage of it as well. All right, and oh man, money on time right there, 2:45. Thank you everyone for coming out. I appreciate it. If you guys have any questions, feel free to drop questions in the chat. You guys can come up and talk to me. You guys can message me on Twitter, on Blue Sky, LinkedIn, any of those. I try to stay pretty active on all of those. So feel free to reach out, and have a great conference, everyone.